Okay, so lastly, we are going to talk about absolute value inequalities. All right, so how do we solve absolute value inequalities? First, let's examine when we have an absolute value of x, and that's greater than or equal to 7. What would that look like? What would the solutions look like? Well, we know that this would apply when any number is greater than or equal to 7. So for example, let's say I had 8, 9, whatever. If I take the absolute value, it's going to certainly be bigger than 7, right? So if I put that on a number line, right, that would look like this. Okay. But also, if I have any number in here that would be less than -7, or less than or equal to -7, that would also work. So like if I did -10, right, or -9 right there, I take the absolute value of -9, I'm going to get 9, which is bigger than 7. So really anything that's less than or equal to -7 also would apply here. So anything down here, right? So really, what does this do? This acts like an OR inequality, right? I have two parts. They're both graphed on there, just like we saw in our last lesson. So that's when you see right here when it's, when this is a greater than or equal to. It acts like an OR inequality. Okay. Let's take a look at one that has a less than or equal to in this case. So this one is the absolute value of x is less than or equal to 4. Okay, so when we think about what could go in here to make this a true statement, we know that as long as anything was less than or equal to 4 here, so here's 4, that would suffice, right? Anything this way. Okay, but also, can I keep going, right? Because if I keep going all the way to here and I get to -7 or -6 there, and I take absolute value of that, now that's 6. That's bigger than 4. So that wouldn't work up here if I had 6 is less than or equal to 4. That's a false statement. So I have to stop somewhere. And where do I stop? Well, as long as this stops at 4 or -4 there, I'm going to be okay, right? It could be -4, take the absolute value, I'd get 4, which is less than or equal to. But it would have to then be bigger this way. But really, I wanted everything in between those 2 points, because anything outside of those is not going to work. So really, this acts as an AND inequality. It's 2 parts, right? So what does this all mean? It really means that absolute value inequalities act just like compound inequalities, because they are. Really, that's the important piece. So they can be a little bit weird. So the compound inequalities part, you really need to know, make sure you know how to do that, and then you can handle these. Okay, so when we did solving absolute value equations in our last unit, we really said, okay, let's get the absolute value expression by itself. In other words, get the absolute value bars by themselves. Then we created 2 cases. One was positive, one was negative. And then we just solved both of those cases, and we had 2 answers. Okay, so when we do absolute value inequalities, this is very, very similar. You're going to get the absolute value expression by itself, or the bars by itself. And then you're going to create 2 cases, and we're going to, this is kind of a way to remember. It's maybe not necessary if you actually understand what you're doing, but if you don't, then sometimes it can help aid to get you a little further. And then we just solve each of those inequalities and then graph them on our number line. So very, very similar, okay? All right, so let's take a look. So here we have a less than 1, right? Less than 19. So this should act as an AND inequality if we do this, but we want to isolate the absolute value bars. It already is, right? So I can create my 2 cases. This is going to be fine as long as 2x minus 3 is less than 19. Okay, cool. But also, if I want this to work, this in here is going to have to be bigger than negative 19, or we're going to have some problems. So our other one is going to be 2x minus 3 has to be bigger. So notice this is going to have to be greater now than negative 19. That's so that we can still get 19 right here, right? So after we take the absolute value. So this is where people sometimes call this the KISS method, because you're keeping this one. So keep it. So it's exactly the same as what you have here. And then the other one right here, we do the same thing, but we switch this and we switch the sign here. So keep it, switch, switch. So that's one way to remember it if you're just not sure how to set it up. So, okay, now that we have it set up, let's solve these. So I'm going to add 3, right, to both sides. And then divide by 2. We're dividing by positive, so we're good. X is less than 11. Okay, now this one's going to solve the same way, right? Add 3 to both sides. We want to divide by 2 again. It's divided by a positive, so we have everything's okay there. And so now this, they will converge, and it's going to act as an and then. So it's going to be where they overlap. So, right, here's 11 and everything less than that. And then x is greater than negative 8. So there's negative 8 and everything greater than. So we're looking for really where they overlap is what we want to put on our number line. So my final answer should be this on my number line. And then you can erase these then if you want. And now that's my answer. Okay, so that's how you solve those, right? Okay, so this one, absolute value, again, already isolated, so we can create our 2 cases, but you'll notice this one is a greater than or equal to, so that means it should act like an or, where you just put them both and they should diverge or go away from each other. But, all right, so I can write my first case. Now, as long as that is bigger than 1 or equal to 1, we're going to be fine. So, but also, if this were less than or equal to negative 1, like negative 2, negative 3, negative 4, and you took the absolute value, then you'd still be bigger than 1. So that's why the other one would be the same, but it would be less than or equal to negative 1. Again, keep it, switch, switch. So if that helps you, use it. Conceptually, I like to just think about conceptually what it is, but again, as long as you understand, you can get these 2 cases. All right, so now we're going to solve. So I'm going to add 5. Okay, and then I need to get this k by itself. It's divided by 3, so we're going to multiply by 3. K is greater than or equal to 18. And on this one, we're doing the same process. We'll get a different result. Okay, and then multiply by 3. We get k is, less than or equal to 12. All right, so this one, greater than or equal to 18, right? And less than or equal to 12. Notice they go away from each other, putting them both on there. This is an or inequality. really. But because they diverge, that's kind of the way you can think about it, that it's or. All right. Let's try a couple more and just make sure that we understand how this process works with a little bit more complicated ones. So again, trying to get the absolute value bars by themselves first, right? I got to get rid of this first before this. So I'm going to add 9. Okay. Okay. And now I want to divide by 3. Okay. So now I've isolated that absolute value bars. So now I can create my two cases. 8x plus 5 is greater than 11. Okay, anything in here, if that's bigger than 11, we're going to be fine. But also, if anything in there was less than negative 11, we'd also be good too. So our other case would be when 8x plus 5 is less than negative 11. Okay, and then we just want to solve both of those. So subtract 5. Divide by 8, divide by 8. I'm going to go underneath my number line here because I'm running out of room. X is greater than, this will be 0.75. And then here, okay, we're going to get X is less than, notice I don't have to flip anything around here, negative 2. Okay, so X is less than negative 2. Okay, and X is greater than 0.75, so 0.75 would be, I don't know, right about here. And then we want to shade everything greater than that. And since they go away from each other, they diverge. It's an OR inequality. Okay, again, just kind of putting those compound inequalities along with the absolute value equations that we did earlier. Okay, one more, and then we're done. And this one's a little bit trickier, but just gotta stay with everything and you'll be all right. All right, so we're gonna add 9. Oh, that's negative. Okay, that's 84, so we're going to divide by 4. (84) divided by 4 is 21. Okay, create my two cases. So I would have negative 3x plus 9 is less than or equal to 21. And then negative 3x plus 9 is greater than or equal to negative 21. All right, we solve these. That would be 12. All right, so this one I want to divide by negative 3. So be careful here. I'm dividing by a negative number on both sides of the inequality. I need to be aware of that and flip my inequality. Now that's also going to happen with the other one too because I have a negative 3x over there too. So just got to keep that in mind. And we have negative 3x is greater than or equal to negative 30. Divide by negative 3. Both sides, so once again here, flipping that inequality, and we get x is less than or equal to 10. So now, x is greater than or equal to negative 4. So, right, that's everything this way. And x is less than or equal to negative 10. So that's here, everything this way. So really what I want to shade is just everything in between there, because that's an and inequality. It's where they overlap. So I really want to just get rid of this part, and my answer would just be where they overlap, which would be that middle part right in here. And that is how you solve absolute value inequalities. Hope that makes sense. In summary, we've learned absolute value inequalities are compound inequalities too. So yeah, that's how we solve those, and we can put those together with solving absolute value equations and compound inequalities. You got it.